There were some questions that were left unanswered, and I would like to answer those. And we would start with the order that they were asked. So the first question is from Kasia. What have you found the most challenging part of commercializing your research? Okay, so we all know that this is a very capital intensive industry. You require huge infrastructure for prototyping, testing, and you need test planes for airborne testing. So the access to funding for such activities has been so far the most challenging part. And then secondly, the lack of an ecosystem, an air commercial aerospace R&D ecosystem has also been a challenging issue. Then we have a question from Jenny. What advice would you give to recent graduates who are starting to build their career in the industry? Okay, so I would tell them to be optimistic, and though at currently the situation seems a bit a bit challenging for the aviation industry, but it is also in its own way very promising, because this is the time when the industry is being encouraged to introduce environmental technologies, new technologies, innovations, and that creates a lot of opportunity for growth for the aerospace professionals. The third question is from Professor Helen. It would be good to understand better whether the water which is recovered is pure or is it contaminated. Could it be used for passengers on the aircraft? Okay, the water is formed through the process of condensation. So just like rainwater is formed, so it is as pure or as impure as rainwater. I mean, the process itself forms very pure water, but since it's a universal solvent, it dissolves contaminants on the way. Water has a tendency to absorb carbon dioxide, to some extent, oxides of nitrogen, sulfur dioxide. So when it is released as rainfall, or when it flows through different channels, even on the aircraft, it would absorb contaminants. So I don't think it would be useful for passengers directly, but we can use it for onboard activities. And one of the suggestions was to, if it could be used for de-icing. But again, that area has not been explored as yet. And secondly, the amount of water that is produced is a lot compared to the onboard requirements. So obviously other avenues have to be sought to dispose of this water or to release this water. Okay, another one from Jenny. What do you hope this industry will look like in 25 years? The industry would definitely be green, because we don't really have another choice. It has to be, we have to support pro-environment technologies, and but the important thing is to support all kinds of environmental technologies, because we don't know which one would mature and which one would take off. Sometimes the best technologies fail in the market because it's dependent on a lot of parameters. But yes, at present, since a lot of they are being sought after, a lot of green technologies are being sought after, so one of them would be the technology of the future. Another one from Cassia. You are clearly passionate about aerospace and environment. What should the next generation of aerospace engineers and leaders be focusing on? Okay, so I would like to say that aerospace is the only industry operating in the sky. All other industries operate on the ground, and the knowledge of the industry in the sky is obviously limited to the aerospace engineers, and it's a very specific technical knowledge. So I think for aerospace engineers, it is our obligation, a professional obligation to keep the skies clean and to sustain the environment and protect the Earth's atmosphere. And since, as I said, that this is the only industry in the sky, so we have to make the rest of the world aware of the issue, and the associated aviation induced global warming, and then also the methods, the way we can mitigate it, the way we can reduce it. And very limited when it comes to global warming on Earth, since it's spread over a wide spectrum of industries. It's very common knowledge. There's a lot of awareness around it. There's a lot of action around it as well. But since the global warming in the sky is only due to the aviation industry, there's limited knowledge. So the aerospace engineers need to focus on it, and leaders also need to focus on it, on the next generation of pro environment aviation. And you need to get support from the rest of the world for it as well. Okay, from Marcos, how do you foresee the COVID-19 crisis to affect the implementation of this technology, given the impact it is having on the aerospace industry worldwide right now? Okay, so I would say that COVID-19 is very short-lived. And we know that the aviation industry has long timelines. Like, we have planes that have been flying in the air for 20 years, and so I don't think that would affect the technology as such. And secondly, now I think the aviation industry is being encouraged by governments to bring in environment friendly technologies post pandemic. And as Rolls-Royce has also announced its support for the hydrogen aviation. So I don't really see the COVID affecting it directly. And in fact, I would say that if the hydrogen technology does take off, it would have a positive impact on this technology as well, because contrails would multiply 3 times with liquid hydrogen fuel. So this would be even more important. Okay, from Noor, what would be the percentage increase of the aircraft weight and fuel burn because of water vapor? Um, Given the high focus by the airline industry on reducing cost, will this be a demotivator for manufacturers to adopt the new technology, and how do you intend to overcome it? Okay, there is a penalty on the aircraft weight, as I just showed in the slide, as well as on fuel burn. And yes, there was a focus by airline industries on reducing costs and maximizing profits, but we do know that now it all depends on uh, the design rubric or the environmental parameter. So now our design parameter is the environment and the global warming potential. So when you use that, then the trade-offs are acceptable. And this has to be, as one of the examples that we cite is that of the A380, where the specific fuel consumption is 2% more than the economy specific fuel consumption, just because it has to comply to noise regulations on the ground. So this is just entirely dependent on the regulations. And for the manufacturers, yes, again, um, it has to be backed by regulation. We do know, although there are a few OEMs, and they are also now looking into technologies, environmental technologies. But as we have the model with the automotive industry, where you have a lot of fancy equipment under your car, which does not directly affect the performance of the car. Rather, probably it compromises the performance, but it is there because the OEMs have to comply with emission regulations on ground, and and they're paying the price for it, and even the consumers are paying the price for it. So this that kind of model needs to be there in the aviation industry as well. Okay, from James, does the engine device fitted cause more drag, significant weight addition, increasing amount of fuel required to overcome? Did you perform a cost benefit analysis regarding the trade off in environmental impacts? Yes, we had this basic preliminary analysis was done by one of my um, co-researchers. I would say I was helping him with this thesis, a master's student, and he used the global warming potential as the parameter to reduce, and then the penalties in fuel burn and weight addition were evaluated according to that, and the results indicated that despite the penalty on fuel burn, the overall reduction in global warming was from 40% to 60%. So initial preliminary trade-off analysis have been done, but a more concise one would probably can be carried out once we complete the performance testing of the engine, and we know the exact parameters, and then they can be used for a more detailed analysis. Okay. From Wajahat, would you like to comment on the artificial rain in a crowded aerospace? Okay, so in a crowded airspace, yes, it has to be optional. I'm sure it would be welcomed in the Middle East, in areas, drought-stricken areas in Africa. But yes, nobody wants more rain on Heathrow. So we are looking at something that, the water could also be, because the main parameter is contrail elimination for global warming. So if the water is not required to be recovered as a byproduct, then it can also be released in the form of ice over the sea, or in any other manner, so that it is not uh, it does not affect the the From Wajahat, would you like to comment on the artificial rain in a crowded airspace? Okay, so basically, yes, I'm sure there are some regions in the world where this water would be welcomed as artificial rainfall, and it has to be released below 2000 meters for it to be, within the weather cycle, for it to act as artificial rainfall. And I'm sure it would be welcomed, if you want to grow a forest around Dubai or Middle East or drought-stricken areas in Africa. But yes, nobody would want more water around Heathrow Airport. So in that case, we are looking at options where it could be dumped midway, or it could be dumped as ice over the sea, and that's something that we are investigating. Okay, the next question is from Professor John Fielding. Aircraft get lighter as they burn fuel and then use less fuel per mile as the aircraft is then lighter. If you store the water, the weight is not reduced, so more fuel will be needed in the start of the flight with weight growth. Is there a way of intermediate water dumps to mitigate this problem? Yes, Professor Fielding, you are right. The plane would not get lighter. It would rather get a little heavier, because 1 kilogram of fuel would release 1.25 kilograms of water, which is the emission index for kerosene. But one of the options is that either you accept the penalty of, flying a heavier aircraft by burning more fuel, but then again, even with that, we are still getting the desired outcomes, that our global warming potential is still reduced by around 40 to 60%. And the other option would be to dump it midway over the sea on long haul flights as ice. And so this is something that I've just started working on this because we were more focused on the development of the engine, but now with one engineer I'm looking at water storage, release and handling. And so far it's on the drawing board, but yes, we are, it's on the way now. One from James. Are you sure the airlines would agree with increase in fuel cost regarding your assumption on environmental trade-off? Perhaps easier to sell on short haul where airtime is reduced. Okay, and have you had any feedback from operators on this concept? Yes, I think this is just, again, this comes down to regulations, because the operators just have to comply with the rules. So whatever the regulations are, and the engines are also developed on certain based on certain specifications that are international industrial standards. So whatever those standards are, they are, the operator has to accept it. So they don't really have a choice. And in terms of, we are trying that the operators or the airlines should be able to sell this water to local governments so that they increase their revenue, and that is like an incentive to adopt pro-environment technologies. And secondly, I think it's now also a matter of how we set our priorities. And with this COVID-19, we know that when something is a necessity, at present we are paying for air, we are paying for clean air. People are buying filters, people are buying masks. This is what the technology is all about. It's about the environment, it's about our planet, it's about reducing global warming in the atmosphere, which has its effect on the climate change on the ground as well. So keeping all that in mind, I think it would take off. And also with the aviation industry now moving towards hydrogen, where with liquid hydrogen you would have 3 times more contrails, and maybe we would only see a white sky, there would not be any blue sky. So I think that there's a lot of promise for all kinds of environmental technologies. So this is the end of all the questions. Thank you very much. Have a nice day. Bye bye. Allah Hafiz.